I hope you guys are doing really well. So we will see today's daily challenge on Leetcode and we will try to solve it together. Okay. So today's challenge is a really interesting one. So although you can try hard and maybe you will be able to come up with the approach, but the coming up with the approach is not much difficult. Okay, but the implementation is actually very difficult. You need to take care that you do not fall into the traps of TLE easily, as it is very easy to fall in this case. Okay, so I will explain you in detail how exactly we can write actually the most optimal code, okay, which will give the greater than at least 90% bits. Okay, I will try to write it at least. Okay, so let's see. Let's understand the problem statement at first, right? That is the most important thing. So find x sum of all k long subarrays. This is the second part, and the interesting thing about this part is that the n and xk everything is in the range of 1e5. Okay, so you need to definitely solve it in n log n. Otherwise, otherwise it will be very difficult to match it. Okay, so let's see. You are given an array nums of n integers and two integers k and x. The x sum of an array is calculated by the following procedure. Count the occurrences of all elements in the array. Keep only the occurrences of top x most frequent elements. If two elements have the same number of occurrences, the element with the bigger value is considered to be more frequent. Okay. Calculate the sum of the resulting array. And note that if an array has less than x distinct elements, is x sum is the sum of the array. I hope those things you can easily take care. And return an integer array answer of length n minus k plus 1, where answer of I is the x sum of the subarray. So basically what you are asked to do here is simply I will just tell that if n is the nums dot size, then okay, what do you need? You need a length which is nothing but n minus k plus 1. I am not coding it the solution right now, but I'm just showing you that what exactly would my vector answer look like. My answer will be of length len. Okay, this is what you need to return. Okay, at the end you need to simply do some processing and return your answer. Okay, so that's what you need to return. And answer of I, what will be answer of I? It will be the x sum of the subarray, this. Okay, so you are also given a k. So for every k window, you see from I plus 0 to I plus k minus 1, it is nothing but k length window. Okay, so let's see the first example. Okay, so let's try to analyze it in detail and not just see this. Okay, so 1 1 2 2 3 4 2 3. So we have it 1 1 2 2 3 4 2 3. Okay, so you have this and you have k to be 6. So you will be having a window length of 6. So this will be your window at first, and then let's say this will be your window, and then let's say this will be your window. So 6 length window you need to consider for k equals to 6 and x equal to 2. It means that top x element you need to select. Okay, the frequency of top x element. Okay, now it goes without saying that definitely you will need to have a frequency map. Okay, so frequency map you will have of the type element comma frequency. Okay, and that you can easily use an unordered map. Okay, I hope you already know it. Unordered map of the type int comma integer you can easily use for that. Okay, but you see, let's try to dry run this at least and see how the answer comes up. So initially your array is containing 1 1 2 2 3 3. Now what are the most frequent element? So you need to select the top two most frequent elements. It is nothing but 1 and 2. Okay, so these are the two most frequent element, and if you just add all of these occurrences of 1 and 2, so it will be basically 1 plus 1, two occurrences of 2 and two occurrences of 1 and two occurrences of 2. If you just add them, it will be 6. Okay, so your answer vector of 0 will be nothing but 6. Okay, so that's how. And if you move to the next window, you are basically using a sliding window, right? So if you move to this window, you will have something like the most occurring element is 2. Okay, so because it occurs 3 times, and the second most occurring element is 4. Why I selected 4? Because in the question it was told that keep if two elements have the same occurrences, the element with the bigger value is considered to be more frequent. Okay, so in this second window 1 2 2 3 4 2, occurrence of 2 is 3 times and occurrence of 4 3 and 1, everything is one time, but 4 will be considered more frequent because that is the largest value. Okay, so I have 3 times 2 and I have 4, which will make it nothing to be 10. Okay, so answer of 1 will be 10. So that's what. And for the last window, I hope you can easily calculate. You will have 2 and 3 as your most frequent elements. Okay, and 2 is occurring 3 times and 3 is occurring 2 times, so it will be 12. Okay, so you will get answer of 2 to be 12, and your answer vector will contain 6, 10, 12. That's what will be your final answer, which you need to return. You see, 6, 10, 12 is what your example 1 also returns. Okay, so I hope at least the question is very clear to you. There should be no confusion regarding the question at least. Okay, and now you see one very interesting thing which comes up is that it is, I mean, within the simulation of the problem, it is clearly told that you have to use a sliding window, man. Okay, so there's no confusion about that this is not a sliding window problem, or it is difficult to understand whether it is a sliding window or not. It is not like that, because it is quite obvious that it is told that you are having a k length window. In the question itself only it's told. So you need to first, so what can you do at first, right? So first what can you do is calculate, let's say, the sum of these, the top elements of these, the top frequent element of this window you can calculate. Then when you are moving to the next window, you can delete this element, right? You can delete this element and insert this 2. Okay, so you are deleting the 1 and inserting the 2 and then moving on to the next window. That's how you can just proceed. You can just keep 2 pointers L and R to keep track. Okay, so when you have moved to the next L and the next R, you are going to remove L minus 1 and you are going to insert R into your calculations, right? So that's how it will work, and just you need to take care of the implementation, and that is all. So you see, you need to get one thing is that answer of I, you need to have the top x elements. Okay, so this is top x most frequent element, top 10 or top 2, whatever, top x most frequent element you need to take care. Okay, so how you will calculate this? You see, uh, for this, can't you keep a frequency, like if it is told that you need to take care of the element which is more frequent, so frequency is the thing which we need to sort. Okay, so you can try to think it something like this. The frequency will be the thing which we need to sort, and if two frequencies are equal, then we need to sort by value. So why not sort this pair frequency comma value? Okay, I hope you do get this, right? So what if you store this in a vector, in and try to sort it, reverse sort it? What will happen? uh, it will sort by frequency value, as it's consider this pair. This, what is this? This is nothing but a pair of integer comma integer, right? If you try to store this in a vector for I hope you do understand, right? If you try to store this in a vector of pair of integer comma integer and try to reverse sort this vector, it will be by default reverse sorted by the frequency, and if the frequencies are equal, it will be reverse sorted by the value. I hope this much you know about sorting a vector of pairs. Now, for simplicity, instead of vector of pairs, I need to have unique elements only. So I will try to have a set of pairs. Okay, I will try to keep a set of pairs, and I will, let's say, call it set. Or now you see, uh, how many sets do you think we need? So first of all, you know that this set will contain frequency comma value. This thing is very much clear, right? And because by that we need to sort it. Okay, now by default the set store from increasing to decreasing, so we can use the greater operator. Okay, greater and data type. I hope you know this. If you do not know, you can just search for this in the Geeks for Geeks, or we will also code it out, then you will understand. We will use just this as the second argument in set, and it will just, instead of storing from smaller to bigger as happens in a set, it will store from bigger to smaller. Okay, so yeah, that can be easily taken care of. So you see, what we can do is that we can have a set, let's say top, which will give me the top x most frequent elements, right? But as you see, but you try to notice one thing in the example which we did. You see, in the first window, what happens in the first window? The most frequently occurring element is 1. But when you go to the second and third window, you see the frequency also changes. Frequency of 1 changes and 1 is no longer the top element. Rather, here 3 was not in the top element, although it was in the first window, but 3 was not in the top element. But when you go to the, let's say, the last window, you see 3 comes in the top element. So this hidden 3 comes up, right? This hidden 3 which was there from the first window itself, it comes up. So how will we detect such kind of cases? So just having a top will not make sure. Okay, so let's say in the first window my top was 1122, right? You do understand what I'm trying to say, right? 1122, my top was this. It will be frequency comma value pair only. I'm just telling that top was 1122, and but you need to keep another set called rest. Rest will be 3 and 4 also. Okay, for the first window I'm telling 3 and 4 also, so that when you go to the future windows and you try to eliminate these ones and you try to include some other elements, you will make sure that when you eliminate this, you must push this rest into your top elements. Okay, so this both should contain this in the same way, so it should contain both of frequency comma value, the highest frequency occurring at first. So you consider it something like this. This is your top set. Okay, this is your top set, so it contains the top x most frequent elements. Okay, and this is your rest. So let's say 2 is here, 1 is here, it is in the top most frequent elements, and let's say 3 and 4 are also here. But in future window, when you will add, let's say, another 3 to this, when you will add another 3, you will realize that 3 has now a frequency of 2, and you might need to bring the most frequent from the rest to something in the top if this top has one element which has gone out. Okay, so top x most element, right? So that's what we will try to do. And you see, if I will try to write a sort of pseudocode something like this. Okay, I will also properly run it, but I'm just telling that if I do something like this, you see, uh, first of all, I had made this answer vector. Okay, uh, now what I do, I calculate for the first window. So as I told you, what I will do is that I will calculate for the first window and I will keep on pushing elements and removing also elements from my window. So let's see. I will consider my first window of length k. Okay, so since I am considering my first window of length k, I will have a loop of length k only. It's quite obvious. And let's say I will write a function insert value. Okay, I will write this function. What will this function do? It will take this nums of I and k, and it will do everything, right? It will make this set. So let's say this set and unordered map. So yeah, one thing is there, that it will have a global variable of unordered map and set. So let's say I will have this unordered map of integer comma integer, right? And let's say I will call that frequency. And for set also, what I told you, that set will be of the type pair of integer comma integer, right? And I will also have a greater, because I need to tell the set that, hey, you need to arrange it in descending order and not ascending order, from smaller to bigger, not you need to arrange it in bigger to smaller fashion. So that's why this set need to be there, and I told you that we will keep two containers, top and rest, for its proper implementation. Okay, so I hope this initialization is clear to you. There should be no confusion. We also have an int sum. Okay, I will call it current sum, because that is the thing which is happening. Okay, so current sum, every time I will calculate. So what it will try to do, it will insert value. It will call a function and it will insert value for the first k window length. Okay, and this value, this function, I will also make it in such a way that it can update this current sum also. And for simplicity, I can just do current sum, answer of 0 equal to current sum for the first window. Okay, now I will go through the next window for the sliding windows. Okay, So I will just call this as sliding windows. So I will have another loop. This loop, as I told you, will have L and R, right? It will have an L and R. So as to take track of the window. So yeah, L will definitely start from 1 and R will, let's say, start from K, right? And R will be definitely less than N. That is the only thing which we need to take care, right? The R is greater than L. R is the right shift, okay, rightmost uh, right end of the window, you can say. And only that if we take care, that is greater than N, less than N, it means L will be definitely less than N, right? And every time what we will do, we will do L plus plus and R plus plus. I hope this loop you easily understood, right? What I am trying to do. I have already taken care of the first window, and I am sliding my window one by one. Okay, so which value I need to erase, as I had already told you. As I am shifting my window, I need to erase my L minus 1 value. Okay, so if I am in the current value L, so let's say I will write another function. See, I had written a function insert value, right? I will write another function erase value, which will do just the opposite, nums of L minus 1 and x. I will also pass this x to tell that to say that basically this top C, this will do everything, right? It will maintain this frequency, it will maintain this set, top, rest. So it needs to know that what is the top x value, right? To store the top x elements. So I need to erase L minus 1, as I had already told you, and insert the R value. So again, I will call this insert value function. What will it do? It will just take nums of R and in the same way x, and answer of L will be nothing but current sum. Okay, current sum also will be updated on calling these two functions. Okay, I will write that in such a way. Okay, and if you see, our main function is quite done. Okay, we will not change our main function, we will just implement our insert value and erase value function. Okay, so eraser, not eraser value, it will be erase value. So I hope this is very clear to you and this is not of any difficulty. So what I can do is that these are void functions, right? It will just change the global variables in some order, and it will also maintain our data structures, unordered map, as well as this set. Okay, so what I need to do is that I need to simply implement these insert value and erase value functions. Okay, so let's see. Let's talk about insert value. We have two elements, right? We have a val and we have x. Okay, so we have it. At first, we have something like frequency, which is the initial frequency, right? So when we are going to insert, we need to update our frequency. That is, we need to increase our frequency to 1, right? But what was our initial frequency? It was nothing but this frequency of val, right? Now, if f is greater than 0, what can I do? You see, if f is greater than 0, I can write it in something. Let's say I extract this pair, which is nothing but, let's say, I will call it FB. Okay, so what it will take? It will take this frequency and let's say its value. Okay, so I just took this pair and let's say I'm trying to find this pair. So what will I do? I have this current frequency. This is the current frequency, not yet updated, right? So see, since I need to change these frequencies, right? I need to change these frequencies also in this. So what does this pair contains? This pair of integer comma integer is nothing but containing frequency comma value, right? As I told you, and I hope you already know the reasons and all. Clearly I have explained you why is it frequency comma value and all. So you see, I just need to find whether this pair exists or not at first, and then we will choose to update it. Okay, we will delete it and then again update it. So let's say I do something like top dot find this FB. Okay, I did this, and I will do if iterator is not equals to top dot end. So it means that if we actually found the element, if we actually found this pair in our top set, what we will do, we will erase it. Okay, because you see the erase that value consists of the old frequency comma value. Now we are going to increment our frequency to by 1, right? And yeah, so that's why I will choose to erase it. And our, since we are erasing this, our current sum will have, if you are getting confused, just stay with me, you will easily get it. Our current value, see, since we are removing this whole thing, frequency multiplied by value will be the sum of all those values, right? So if let's say 3 contains 5 times, you need to multiply 3 into 5 to remove all those 3's. Okay, so and else what you can do, if it is not in the top, it is definitely in the rest set. Okay, and you can do rest dot erase this fb. This fb is a pair, right? This is a pair integer comma integer, so you can choose to remove this. Okay, and since you have removed this, so what do you need to do? uh, if this contains some frequency and you remove this frequency, you need, what you initially needed to do was to add the frequency by 1. So you can do something like top dot insert of f plus 1 comma val, right? So basically you remove the set f comma val and you are inserting, so removed f comma val, inserted f plus 1 comma val. Okay, I'm not choosing to update this, because update this f to f plus 1, because that will create some confusions. Okay, if you want, you can just go with that approach, you will find why I'm telling you not to do. So yeah, this top dot insert, and you see this current sum was subtracted. Now it needs to be incremented, right? So incremented by how much value? Is definitely by this f plus 1 into value. Okay, yeah, so that is what, this current sum must be long. Okay, you need to take care of that. And let's say I will also write this hash define ll long. Okay, I will just do this. And you see, now I need to make sure of the top and the rest, right? I've already explained you why we need the top and the rest, two different elements. Now if top dot size, on inserting the current element, if we see that top dot size is becoming greater than x, so see, that's why I took x. If I see that top dot size is becoming greater than x, so what we can do in such a case? In such a case, what we can do is that we can do it, so is equal to previous of top dot end. Okay, so the last element is nothing but this top dot end, means the element after last, iterator after last. So that's what you can do. So let's say you are trying to bring, if the top dot size is becoming greater than x, what do you need to do? Try to understand. Okay, do not just see, try to understand. If you see that you inserted one element and now after insertion it become greater than x, okay, the count of top become greater than x, what do you need to do? From rest you need to bring it to top. So that's what you will want to do. So you want to remove the less frequently occurring element of top and take the more frequently occurring element from the rest. So yeah, you took the less frequently occurring element from top. Okay, that's what. And what did you do? You just inserted, did something like, yeah. So basically I told just the opposite. I hope you do understand, right? As you are inserting element into this top, okay, you see that if it is greater than x, okay, so the least frequently occurring element you move from top to rest. Okay, so this is the top and this is the rest. It contains top x most frequent occurring elements. Now while inserting an element in the top, you see that I have inserted it, but the now it is not the top x most frequent, it is something more than x, right? It is just greater than x. So what do you need to do? You select the least frequently occurring element and move it to the rest. Okay, so that's what I am trying to do. It is selecting the least frequently occurring element from the top and it is moving into this rest. Star it is the value at the iterator it. Okay, and we'll also have top dot erase it. we will erase this from the top, because the top in order to maintain this size of the top. And you see what we will do, we have this current sum, right? So since we are choosing to actually take this away from the top, so what is current sum? It is the sum of the top x, sum of all the values of this top. So if you are removing something from the top, you must remove it from the current sum also. So I hope that will be very simple, and you can just do IT arrow first and IT arrow second. Okay, I hope you do get this. This is nothing but the frequency comma value, which I have been doing again and again, so I just not explained you much regarding this. This is nothing but this frequency array. Okay, so yeah, you can do it, and that's all about the insert value function. Now we can go ahead with the erase value and write it in the same way. So if you are feeling any difficulty, see, you can definitely ask me in the comment section, but yeah, you also try hard and try your best to understand how you can try hard. See, I wrote the insert value function, so I am giving you the task to pause the video and write the erase value function on your own, right? Because it is the exact same thing, right? So it will be is int val comma x, and everything, almost everything, it will be the same, right? I can almost copy this and make some changes definitely. So this frequency value, this will return. Okay, and let's say I'm trying to erase the value, right? What if frequency is 0? So if you get something like frequency 0, you cannot erase anything, right? So just return it. If you cannot erase anything, what else will you erase? So you just return it. Okay, so that's what, and there is no case of actually doing this. So f greater than 0, there is no point in checking f greater than 0. And for this, you just take care that this pair is nothing but f comma val, and this it is also top dot find. Okay, and if it is not top dot end, you can just erase it. You can subtract this car dot sum, right? And else what you can do, else you can erase this thing. So this whole thing will still take place, right? So yeah, so you can just do this, and yeah, so you have it. And you see one thing, you can do another check, that if see, erase, we need to increase the decrease the frequency, right? So if f minus 1 is equal to 0, right? So after this erase, you can just erase this frequency frequency dot erase this value, right? You can just do this, and else if it is not, you can just insert into your rest, which will be nothing but f comma value. I hope you do get it, right? You do get it. And what do you need to do next? Okay, so see, these things will change actually. So yeah, what we did here actually was that we are trying to insert element, so the top might get something greater than x. Here it is just the opposite. Here it is just the opposite, right? So what can you do here? You can just write the opposite thing. If top dot size is rather less than x, or and you just check also that if rest dot empty, if it is not empty, okay, then what you can do, you can move from rest to top. So what I'm trying, see, last time while inserting, see, you are inserting, as you are inserting element to the top might overflow, and you might require to move elements from top to rest. Okay, but what if your top has top x elements and rest has the remaining? So if you want to erase elements, so let's say you want to erase this element from the top, and it got erased actually from the top, then top might have some deficient number of elements. In that case, you will be requiring to move your top element from the rest into your top. Okay, so I hope you get it. Okay, just the opposite thing you need to do. So auto it is rest dot begin. Okay, see, last time what I had done its end, but now I am choosing it to be beginning. Why? Because the most frequent occurring element of the rest I need to change, right? And since I am adding element into my cursor right now, I will definitely do a plus equals to, and after this long I will have a simple this thing only, right? So yeah, let me just copy it. Yeah, so we have it, and once we have our current sum, what we can do is that top dot insert star it, as we are inserting element into the top, and for the rest dot erase it. Okay, so that's all. You see, that's all, and we are done completely with our solution. You can just choose to submit it. Let's see if it works or does it have some error. Hmm, indicate required pointer operand. So this is not multiply, right? This is just typecasting. So yeah, uh, again the same thing, right? L will be just typecasted. You do not need to multiply it. It's there here also. Yeah. So you see you can also multiply one long, right? You can also multiply one long, or just try to typecast it. Return answer. So answer will contain long, right? So yeah, that is what. Okay, so you are getting a wrong answer. So you see, we missed a number of things. So if f minus 1 is 0, we are erasing this value. And afterwards, we need to write f minus 1 into this rest only. Okay, because we are decrementing the frequency. And the most obvious thing which I missed was that in insert value, we are actually never updating this frequency map. So, and which is the most important thing, right? So for insert value, you definitely need to increase this frequency. I hope you would have caught my mistake if you were listening really correctly, because if you are listening attentively, this is, I guess, very trivial that you need to decrease the frequency during the erase value and the insert value also. And what else there was another mistake is that this k. Okay, so yeah, just it's a typo, you can say, like it will be just nums of I comma x. And a few more changes which you need to do is that this typecast is actually wrong. First is this has to be typecasted, and then you can multiply it, right? Or you can just choose to multiply the thing. Okay, so this has to be typecasted first, uh, and then only you can choose to multiply it. Okay, so you need to put an extra bracket. Same for this. And let's see more of such cases where we have done. This is correct. And yeah, this is another thing which you need to do. uh, just typecast this, and I hope now it should work fine. Let's try to submit and check after all this debugging. Yeah, our code is now running fine. If we try to submit it, we will see that I hope there should be no error. You see, we also get a really good runtime and memory complexity. So I hope uh, at least the approach and the intuition as well as the implementation, which is the major thing right here, uh, was very clear to you, and you have no confusion right now. If you did understand, definitely write me in the comment section, and if you did not understand, then also write in the comment section and tell me that which part was difficult to understand. And yeah, otherwise I hope that's all for this video. I will meet you in the next video. Till then, thanks a lot.